I've held it in my hand at Ben's lab in Hong Kong, which is almost done now, but still needs some editing and fine-tuning. It's sort of a large and unruly beast. It's almost 900 pages, which is why it was 2 volumes, and divided into 2 parts. The first part outlines my general approach to the problem of building advanced AGI, and the second part reviews the OpenCog AGI design, not at the software code level, but at the levels of algorithms and knowledge representations and data structures and high-level software design. Part 1 briefly reviews the patternist theory of mind I outlined in a series of books earlier in my career. General comment here. Ben is a 186 IQ genius, right? And he's 20 years younger than I am, so I guess that makes him 50 this year, 2017. And he already has a string, and I mean a string, long string of books. He must have about 20 now, and he's only 50. So that's what you can do when you have a genius IQ, 186. I kid you not. Part 1 briefly reviews the patternist theory of mind I outlined in a series of books earlier in my career and summarized in The Hidden Pattern in 2006. Basically, a mind is a system of patterns that's organized into a configuration that allows it to effectively recognize patterns in itself and its world. It has certain goals and is particularly oriented to recognize patterns of the form, if I carry out this process in this context, I'm reasonably likely to achieve this goal or sub-goal. The various patterns in the mind are internally organized into certain large-scale networks, like a hierarchical network, and an associative hierarchy, and a reflexive self. The problem of AGI design then comes down to how do you represent the patterns, and via what pattern processes does the pattern system recognize as new patterns? This is a pretty high-level philosophical view, but it's important to start with the right general perspective, or you never get anywhere on the AGI problem, no matter how brilliant your technical work, nor how big your budget. Another key conceptual point is that AGI is all about resource limitations. If you don't have limited space-time resources, then you can create a super powerful AGI using a very short and simple computer program. I pointed this out in my 1993 book, The Structure of Intelligence, and others probably saw it much earlier, such as Ray Solomonov and Marcus Hutter rigorously proved it in his work on universal AI a few years ago. So real-world AGI is all about how do you make a system that displays reasonably general intelligence, biased towards a certain set of goals and environments, and operates within feasible space-time resources. The AGIs we build don't need to be biased towards the same set of goals and environments that humans are, but there's got to be some overlap or we won't be able to recognize the system as intelligent, given our own biases and limitations. One concept I spent a fair bit of time on in part 1 is cognitive synergy, the idea that a mind to be intelligent in the human everyday world using feasible computing resources has got to have multiple somewhat distinct memory stores corresponding to different kinds of knowledge: declarative, procedural, episodic, attentional, intentional, goal-oriented, and has got to have somewhat differing learning processes corresponding to these different memory stores. And then these learning processes have got to synergize with each other so as to prevent each other from falling into unproductive, general intelligence killing combinatorial explosions. In the last couple of months, my friend and long-term collaborator since 1993, Matt Ikle, I-K-L-E, and I put some effort into formalizing the notion of cognitive synergy using information geometry and related ideas. This will go into building better minds too. Also, meaning also. So he then he used the modern title, current title. This will go into building better minds too. One of my jobs this month is to integrate that material into the manuscript. We take our cue from general relativity theory and look at each type of memory in the mind as a kind of curved mind space, and then look at the combination of memory types as a kind of composite curved mind space. Then we look at cognition as a matter of trying to follow short paths toward goals in mind space, and model cognitive synergy as cases where there's a shorter path through the composite mind space than through any of the memory type specific mind spaces. I'm sort of hoping this geometric view can serve as a unifying theoretical framework for practical work on AGI, something it's lacked so far. So ad-libbing here, do you get a taste, a sense of Ben's 186 IQ when you hear this sort of stuff that he speculates on? That's why he's my best friend. In fact, he's the only guy that I can share all of my mind with. The only person on the planet that I know that I can do that with. So I have enormous respect for him. And I think a lot of other people feel the same way. Then, at the end of part 1, I talk about the practical roadmap to AGI, which I think should start via making AGI children that learn in virtual world and robotic preschools. Following that, we can integrate these toddler AGIs into our narrow AGI programs that do things like biological data analysis and natural language processing, and build proto-AGI artificial experts with a combination of common sense intuition and specialized capability. If I have my way, the first artificial expert may be an artificial biologist working on the science of life extension. Wow! Following up the work I'm doing now with narrow AI in biology with BioMind LLC and Genescient Corporation. And then finally, we can move from these artificial experts to real human level AGIs. This developmental approach gets tied in with ideas from developmental psychology, including Piaget, plus more modern ideas. And we also talk about developmental ethics, how you teach an AGI to be ethical and to carry out ethical judgments using a combination of logical reason and empathic intuition. I've always felt that just as an AGI can ultimately be more intelligent than any human, it can also be more ethical, even according to human standards of ethics. Though I have no doubt that advanced AGIs will also advance beyond humans in their concept of what it is to be ethical. That's part 1, which is the shorter part. Part 2 then goes over the OpenCog design and some related technical ideas, explaining a concrete path to achieving the broad concepts sketched in part 1. I explain practical ways of representing each of the kinds of knowledge described in part 1. Probabilistic logic relations for declarative knowledge, programs in a simple Lisp-like language for procedural knowledge, attractor neural net-like activation spreading for attentional knowledge, movies runnable in a simulation engine for episodic knowledge, and so forth. And then I explain practical algorithms for dealing with each type of knowledge, probabilistic logical inference and concept formation, and some other methods for declarative knowledge. Probabilistic evolutionary program learning, MOSES, M-O-S-E-S, for procedural knowledge, economic attention networks for attentional knowledge, hierarchical deep learning using Itamar RL's Destin algorithm for perception, etc. And I explain how all these different algorithms can work together effectively, helping each other out when they get stuck. And finally, how due to the interoperation of these algorithms in the context of controlling an agent embodied in a world, the mind of the agent will build up the right internal structures like hierarchical and heterarchical and self-networks. I'm saying I here because the book represents my overall vision, but actually I have 2 co-authors on the book, Neil, that's N-I-L, Neil Geisweiler, 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 and Cassio Pennakin, Pennachin, and they're being extremely helpful too. I've been working with Cassio on AI since 1998, and he has awesomely uncommon common sense and a deep understanding of both AI, cog-sci, that's cognitive science, and software design issues. And Neil also thoroughly understands the AGI design and is very helpful at double-checking and improving formal mathematics. I understand math very well. That was my PhD area way back when, but I have an unfortunate tendency to make careless mistakes. The 2 of them have written some parts and edited many others, and there are also co-authors for many of the chapters who have contributed significant thinking. So the book is really a group effort, orchestrated by me but produced together with a lot of the great collaborators I've been lucky to have in the last decade or so. Now, so far our practical work with OpenCog hasn't gotten too far through the grand cosmic theory in the Building Better Minds book. We've got a basic software framework that handles multiple memory types and learning processes, and we have initial versions of most of the learning processes in place, and the whole thing is built pretty well in C++ in a manner that's designed to be scalable. The code now has some scalability limitations, but it's designed so we can make it extremely scalable by replacing certain specific software objects without changing the overall system. But we've done only very limited experimentation so far with synergetic interaction between the different cognitive processes. Right now, the most activity on the project is happening in Hong Kong, where there's a team working on applying OpenCog to make a smart video game character. We're going to get some interesting cognitive synergy going in that context during the next couple of years. The argument some people have made against this approach is that it's too big, complex and messy. My response is always, okay, and where exactly is your evidence that the brain is not big, complex and messy? The OpenCog design is a hell of a lot simpler and more elegant than the human brain appears to be. I know a fair bit of neuroscience, and I've done some consulting projects where I've gotten to interact with some of the world's greatest neuroscientists, and everything I learn about neuroscience tells me that the brain consists of a lot of neuron types, a lot of neurotransmitter types, a lot of complex networks and cell assemblies spanning different brain regions which have different architectures and dynamics and evolved at different times to meet different constraints. The simplicity and elegance that some people demand in an AGI system seems utterly absent from the human brain. Of course, it's possible that once we find the true and correct theory of the human brain, the startling simplicity will be apparent, but I doubt it. That's not how biology seems to work. I think we will ultimately have a simple, elegant theory of the overall emergent dynamics of intelligent systems. That's what I'm trying to work towards with the ideas on curved mind space that I mentioned above. Whether or not these exact ideas are right, I'm sure some theory of that general nature is eventually going to happen. But the particulars of achieving intelligence is in complex environments using feasible computational resources. I feel that's always likely to be a bit messy and heterogeneous, involving integration of different kinds of memory stores with different kinds of learning processes associated with them. Just like the theory of evolution is rather simple and elegant, and so is the operation of DNA and RNA, but the particulars of specific biological systems are always kind of complex and involved. I'm sure we didn't get every detail right in Building Better Minds, but we're gradually pulling together a bigger and bigger community of really smart, passionate people working on building the OpenCog system, largely inspired by the ideas in that book, plus whatever other related ideas team members bring in, based on their own experience and imagination. The idea is to be practical and use Building Better Minds and other design ideas to create a real system that does stuff like control video game characters and robots and biology data analysis systems, and then improve the details of the design as we go along, and improve our theories as we go along, based on studying the behaviors of our actual systems. And once we get sufficiently exciting behaviors, trumpet them really loud to the world and try to create an AGI Sputnik moment, after which progress will really accelerate. Singularity, here we come. And that's the end of a very long flyer. So that was an interview I had with Ben Goertzel, oh God, how many years ago? 6, I guess. Yeah. We talked about 2011, so 6 years ago. So it's starting to age a bit. Perhaps I should interview Ben again to get an update on what's been going on over the past 6 years, because he has quite a team in Hong Kong, and he may stay there unless some major finance breakthrough occurs. So he's been there, what, six years at least. Well, about 6 years, I suppose. So, okay, so I'll end there. Ciao. Prof. Dr. Hugo de Garis. Email profhugodegaris@yahoo.com. Website profhugodegaris.wordpress.com. And YouTube channel name Hugo de Garis. Ciao.